Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Atrocious Destruction by NXT Master. And here are the rules. We have standard irregular 8x8 Sudoku rules apply, except the given regions are false and must be destroyed by making sure none contain all the digits from 1 through 8. Additionally, the real regions, which do contain all the digits 1 through 8, must be deduced such that the digits in a circle represent how many of the surrounding 8 cells and itself belong to the real and false regions the circle is in. Circles basically count overlap. Okay, what does this mean? So, irregular 8x8 Sudoku rules apply, which means fill every cell in the grid with the digits 1 through 8, such that every row and column contain the digits 1 through 8 exactly once each. All the designated 8-cell regions do not contain the digits exactly 1 through 8 each, or do not contain the digits 1 through 8 exactly once each. But there is a region, there is 8 other regions which are not shown on the puzzle, which do contain the digits 1 through 8, and they are orthogonally connected, which means that you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this would potentially be a valid example of a orthogonally connected region. In addition, the circles indicate around that cell how many of the 3x3 cells around that cell are in both the false region, which are in the designated 8-cell regions, and in the real region that circle is in. So, for example, say this was the region here. This would mean it has 3 cells. Okay, so this cannot be a valid region then, because we know that this has 3 cells that are both in the designated region, which is false, and the real region, right? These 3 cells are both in the designated false region and in the real region. But this one also has these cells in the real region, in the 3x3 area surrounding this cell, and in the false region, the designated false region. So therefore, both of these would have to be 3 by definition, but because the real region has the digits 1 through 8 exactly once each in that region, this cannot be the actual region. As an example, this would be 1. Because in its designated false region, there's only 1 cell in the 3x3 space surrounding this circle. And in the real region, there's only 1 cell, right? Just the cell itself. So that's an example of how these circles work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So we have certain restrictions on rows and columns. The circles are usually the ones that are most interesting. This circle can have at most 4 cells which are both in its designated false region and its real region. So this is up to 4. And it cannot be 1. This can only have 3 cells in its designated false region and its real region. So this is 1, 2, or 3. This can have up to 4 cells in the same designated false region and its real region. So this is 1 through 4. This cell can only have 3 cells in its designated false region and real region. So this is 1, 2, or 3. This is also 3 here. And this has to be 2 or 3 because there's a 1 in the column. Because these 3 are the only possible ones to be in the false and real region. We have 3 here, because these cannot be in the designated false region, so this is 2 or 3. We have a 2, 3, 2, 3 pair in column 2. So this cannot be 2 or 3. This has to be a 4, because there's only 4 possible cells that can be in both the false, designated false region and the real region. So the real region has to be here, at least, these 4 cells. This cannot have 4, and these 3 are already in the same region, so this must be 3. That means this is not in the same region, so we have a boundary here for the false region. So this part is another region. This cell is in the same region as these. It must be specifically 2, because it could have been 2 or 1, 2, or actually it could be 1. No, it's 2, because it's these 2, right? So this has to be 2. So therefore, we have a boundary here also. Whoops. I don't know how that gets set. So we have a boundary there also. So this red must go out somewhere here. This can only be 3 at most here. Cannot be 3. It's 1 or 2. This can be 3 at most, but it can't be 3 because of 3 in the row. Can't be 1 because of 1 in the column, so this must be 2. So this is 2, this is 1. So we know there's a boundary here and a boundary here. This must share with one of these. This is only 1, so this is a boundary here. This can't be 2. This cell can only have 3 that are in the same real region and boundary, so this must be 3, which makes this 4. So this is a full 4 here. Therefore, these are all in the same region. This can't be 4 then. This is at least 3, so it has to be 3 here. So this is 3, this is 2, this is 1. So we have boundary here. We have boundary here and here. This shares at least 2, so this is 2 here, which means this is a boundary here. This must be part of dark, because if it's not part of dark, the problem is that it's not part of any other region. It's not part of this region because this only shares the real and the false region with itself. So this must be dark here. This must be dark here. It must extend out this way. It cannot extend here. None of these could be 1. We need access to a 1 for the dark region, and I can only get access to the 1 here. So this is 1, and this is done as a region here. So let's do the boundary of the entire grid. This is done as a region. So that's 1. We are missing 5, 6, and 8 here. Not 9, 5, 6, and 8. Remaining digits of row 8 are 1, 3, 5, and 8. Obviously, this can't be 1 or 3. This can't be 3. This can't be 1. This can't be 1 or 8. So the remaining... So where is 1 in row 8? It has to be here. So this is 1. We're going to make this orange and this blue for the 1s. Can red go out here? It's possible. So this is a 1 also. And in fact, it actually does. It's similar situation for the red, right? This cannot share a region with either of these 2 cells. The red has to go out somewhere. It can only go out this way. And it needs access to a 1. Can't go this way, then it has to go that way. So this is red as a region, and that's done. So we're going to make this blue, orange. We're going to make this yellow. We're going to make that green. 2 eliminates 2 here. This is 3. So these are all the same region, and this must be part of that region, because otherwise, if it's not, this would only be a 4-cell region at most. So this has to be green all this way. That means all of this is filled out with green. And we have one access to green in one of those cells here. Okay. Remaining digits in column 7 are 5, 6, and 8. 5, 6, 7, and 8. This digit can be up to 5. So this is 2, 3, 4, 5. I'm going to make this... We have how many? 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. We need a 1 for the red. So that's 7. That means we have 7 ones available. We know where the last one has to be. It has to be here. So this will be 8. So we'll make this one pink. And this one will make medium gray. Okay. This is all the same region. Not sure which one that is. We're going to make that light gray for now. 2 out of these are the same region. Okay. Remaining digits, so this can't be 5 here in the dark region. So 5 in the dark region has to be one of these 2. We're missing 5, 7, and 8 left in the red region. In column 2, we have 5, 6, 7, 8, 5, 6, 7, 8. No 5 here because of 5 in the row. And 5, 6, 7, 8. No 7 or 8 here. So in the rest of row 1 are 3, 5, and 6. This can't be 5 because of 5 in the column. So, interesting. This is one region here. 1, 2, 3, 4, 5, 6, 7, 8. Remaining digits of column 8. We have 2, 4, 5, 6, 8. No 5 here. No 2 here because of 5's in the column and 2 in the column. Remaining digits of row 7. 4, 5, 6, 7, 8. This can't be 8 because of 8 in the column. Okay, what happens if light is not the same region as orange? Orange could be 1, 2, 3, 4, 5, 6, 7, 8, but it doesn't have access to a 3. Even if it went orange, orange, I guess it could be light. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. It just doesn't have access to a 3 otherwise. These digits, what are these digits? Cannot be 1 or 2, so 3, 4, 5, 6, 7, 8. But there's no 3 here because of 3 in the region. This 3 says that 3 cells in the surrounding 3x3 box are in the real region and the designated fake region. So it must be all 3 of these. Well, then where is 3 in column 6? It must be here, which makes this 5, which makes that 8. 8 cannot be here or here or here. That means where is 8 in the dark region? It's one of these 2, which eliminates 8 in the rest of the column. So there's no 8 there. Again, if light were different than orange, how does orange get access to a 3? It can't. Because it can't go through here. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And then can't access 3 here or 3 here. So this must be the same as orange. Blue could go here, obviously. Can this ever be a different region? The answer is no, right? The orange has to connect. This can't be a different region, then it would be a single cell by itself. So this has to be part of orange. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Is that possible? No. Because the problem, so if this were 5, it would have to be all of this is the same region. So we would have 1, 2, 3, 4, 5, 6, 7, 8. And the problem is yellow would have to go out and then exit. But then this is a separate region than this because of the 1 in the circle. So this cannot be 5. It still could be technically 4 with these 4. 1, 2, 3, 4, 5, 6, 7. And then say 8 here, right? That's possible. And then the yellow could go out. Yeah. So this is not necessarily a different region than these. Okay. Can this ever be non-orange or non-blue? That would mean it would have to be either pink, 1, 2, 3, 4, 5, 6, 7, 8. But then the problem is this would have to be 2 because it would have only 2 cells which are the same region as the circle and in the false region. This can't be 5. Remaining digits in column 5 are 2, 3, 4, 6, 7, 8. No 3 here, no 3 here. No 8 here. I don't know how I got 8. Okay. So again, if this were not orange or blue, the thing is, or rather the issue is, so if it tried to be pink, that this would have to be 2 here also, which is not allowed. And if it's tried to be yellow, I guess it could do something like this. But that is potentially possible. It couldn't go here and then go around, right? It couldn't go here and then go around for the yellow. Okay, so the problem with this is that where would blue then get access to a 3? It wouldn't have access to a 3 because it'd be blocked by the yellow. So this has to be blue or orange here. We don't know which. And in this part, we have guaranteed a 2 in one of these 4 cells. And it must be part of blue or orange here. So this is all blue or orange as possibilities. How many digits is that, or cells is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 5 more blue and oranges, which is quite a decent amount. Okay. Twos. 2 cannot be here. 2 could be here, potentially. Remaining digits in column 1, 2, 4, 5, 7, 8. No 2, no 5, because of digits in the rows. Column 4. 2, 3, 4, 6, 8. No 2 or 3, no 3, no 3. Because of 2s and 3s in the rows. What about column 3? We have 3 through 8. No 3, no 5, no 3 because of digits in the rows. Okay. Say this was a 4 as part of the orange. It can only be 4 if it's part of the orange. Because if it tried to go this way, the problem is one of these is orange, right? So say it was part of orange here. That means one of these two is also orange. The other is not. We'd have 1, 2, 3, 4, 5, 6, 7 oranges. Only one of these could be orange. So that means the rest are blue. So we'd have 1, 2, 3, 4, 5, 6, 7 blues. But that blue doesn't have access to the 3. So this cannot be orange here. So this is a boundary here, guaranteed. So this is either 2 or 3 here. Can it be blue as 3? 1, 2, 3, 4, 5, 6, 7, 8. But the problem is the yellow is at most a size 5. So this cannot be blue. So the blue, to have access to a 3, must get access here. So this is blue. That means to get access to here, this has to be blue, right? Because if it was another color, you wouldn't have access to the blue from there. So this is guaranteed 3 and 8 and 1. So you cannot have the full blue here. Because if it were full blue here, the problem is it would have access to an 8 in one of these cells. And it would have to have all of them because you can't go around because that would not have a region then. So this cannot be blue. This is guaranteed to be orange. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 blues and oranges, which means we have one more left. So this could be orange. This could be blue or orange, and this could be blue potentially. So this is a completely different region. You cannot have this being blue here. So this has to be like pink or orange. It can't be either. Oh, wait, hold on. So 1, 2, 3, 4, 6, 7. This has to be 2 going up. It cannot be yellow. It can't be blue or orange. This needs to be accessing a different color, so it must be pink. And if we try to block that off, the yellow gets blocked. So the yellow has to go up that way. So this cannot be orange here. This is pink. And this must be just 2. So this is 2. Which eliminates 2 in the rest of the column. We have a 4, 6, 7 triplet in column 5, which eliminates 4, 6, 7 in the rest of the column. So this is 3. So pink could go either of these spots. Yellow could go all the way to here. Pink could technically go here. Actually, no, it can't. Yellow has to X. This is at most 1, 2, 3, 4, 5, 6. Right? So it can't go further here because blue needs access to the 3. So this is definitely a boundary. These are definitely boundaries. The pink has to go up all the way to here. So this is 4, 6, and 7, so this cannot be pink. That's the reason why. Pink needs access to an 8. The only access to an 8 would be here. So this is pink. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And one of these... this could be pink. No, it can't be pink. If this is pink, that blocks off the yellow. So yellow has to go there. Green cannot go there because that would block off yellow also. So green has to be one of these 3. These could be all gray here. We have 6 yellows, so we can go 1, 2 potentially this way. We could go 1, 2 that way. We could go 1, 2 that way. We need access to a 5, and we can't go here. So pink is one of these, and one of these is 5. Okay. 3 eliminates 3 here. Okay. This is definitely a boundary here. Where is 3 in row 6? Can't be here because of 3 in the region. Can't be here because of 3 in the region. This is 2. This can't be here because 3 in the region. Can't be here because 3 in the column. Can't be here because 3 in the column. 3 has to be here. So this is 3, which makes this 6, which makes this 5, which makes that 3. These are all gray because these are the only possibilities. So this can't be 5 here. We're missing a 4 and a 6 here. This can't be 6. No 6, no 6. Blue needs access to a 7. So if we tried... So one of these is pink. Can this ever be yellow? If this were yellow, the problem is pink would have to go this way. So that's 8. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cells for 2 8-cell regions, which is not possible. So this cannot be yellow. So this is definitely a border here. This can't be 2 because of 2 in the row. Same with this 2. Green needs access to a... Oh, no, green has a 1. Okay. Hmm. We know this is a border because it can't go 6 here because we already have 4, 6, 7 triplet here as pink. Um, let's remove some of the boundaries. It's kind of hard to see the fake boundaries with these. So I need to see the fake boundaries to be able to see um, what is supposed to be part of the same region. So this cell, so these are all the same in the same region, or the same false region, and they're in the same row. So this cell cannot be the same as this one. That's all we know. Okay. This region already has 2 3s, so that's fine. This region already has 2 1s, that's fine. This region does not have a 1, so that's fine. This region does not have a 7, so that's fine. This region has 2 3s, so that's fine. Region has 2 1s, so that's fine. We have a 1 here. This cell cannot be the same as that. Okay. We know 5 has to be one of these two, so this can't be 5. This can't be 5. This can't be 5. So one of these two is a 5 here for the red region, so this can't be 5 here. This can't be 2. If this were 2, that would force this to be a 4-8 pair, which would force that to be 2, and then this would be a full region of the digits 1 through 8, because this would be forced to be 2. So this cannot be 2 here. Hmm. Okay. Um. So we have a guaranteed 2 in the yellow region. Can... Hmm. Interesting. Huh. So yeah, the only ones where we don't have false regions are these two. Hmm. Okay. This is where we get to the hard part of the puzzle. Hmm. Green, we don't know what digit we're missing. We definitely have a 5. One of these 3 digits is a 5. Yellow, we're missing a 4, 1 out of 4, 8, and a 6. So this could technically be 4 6 here. Or I could just go straight up, right? Oh, this can't be gray because only two of these are in the same region. So this can't be gray, which means this is yellow. So we have 1, 2, 3, 4, 5, 6, 7 yellows. So one of these two is a yellow here. So this can't be yellow here. This cannot be yellow here. That's gray. So this is done as this is done. Same with that. Boundary. Boundary. Boundary here. 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 One of these is guaranteed to be a 6 because yellow needs access to a 6, so this can't be 6 here. So let's look at the circles again. This does have 2 in the real and the fake region. This has 1 in the real and the fake region. This has 2 in the real and the fake region, 4 in the real and the fake region, 3 in the real and the fake region, 1 in the real and the fake region, 3 in the real and fake region, 1 in the real and fake region, 3, 4, 2, 1, 2, 3. We still don't have this one yet, so we don't know about that. What happens if it's orange? You'd have to have access to an 8, so this would be 8 then. So say 1, 2, 3, 4, 5, 6, 7, 8. Or you could have blue all the way around here. Or sorry, orange all the way around here, and then this is blue. We don't know if this is a boundary here. That's incorrect. What happens if this is 8? That's interesting. So if this is 8, this is 6, that's 5, 8, 4. No, 4, 8, that's 7, this is 6. No, 6 or 8, that's 7. That leaves this as 4. This can't be 4, this is 2, 8 as a pair. That would be 2 here. Green would need access to a 2, so this would have to be 2. And then we'd have a problem. This would be a contradiction because this couldn't be green anymore. And then we'd have 2 7s here, which is not allowed. So, if this were part of the orange, 2 of these would be part of orange, and none of them could be 8. Therefore, this would have to be 8, and then we would run to a contradiction that way. So this cannot be orange. This must be blue. So this is blue. So we have 1, 2, 3, 4, 5 blues at minimum. So that means only 3 more. So this can't be blue. This is orange, at least. We have 1, 2, 3, 4, 5, 6, 7. So only 1 more orange is available. 1, 2, 3, 4, 5, 6. And then 2 out of these sets. So this can never be 8. That's what we figured out. So one of these 2 has to be an 8 for the orange cell because none of these can be. So since one of these 2 is 8, this can... Okay, well, yeah, this can't be 8, this can't be 5, this could be 5. We don't know if this is blue or if it's pink. So one of these two is a 5. We don't know which. Hmm. Um. Hmm. Okay, so we are guaranteed a 6 in one of those cells in rows 2 and 3. We are guaranteed a 6 in one of these 3 cells in rows 2 and 3. So the rest of rows 2 and 3 cannot contain a 6. So no 6 here, no 6 here. Um... One of these two is a 7. And the other one there's a boundary with. So this cannot be 7 here, then, because one of these two is guaranteed to be the blue 7. Remaining digit is 4, 5, or 6 for blue. Um... Ah, we can't have 8 here, 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 or here in rows 7 and 8. So where are the 8s going to be in, sorry, rows 6 and 7? So where can the 8s be? One of them's in the red, the other one must be in green. So this is 8 here, which eliminates 8 in the rest of the column and the rest of the region. So this can't be 8, this can't be 8. We now know where are the 8s in row 4 and 5. One of them has to be in the yellow region, one of them has to be here. So this must be a 2-8 pair, which eliminates 2 and 8 in the rest of the column. So this cannot be 8, this is 4, which eliminates 4 here, so it's 7. This can't be 4 or 7, it's 6 or 8 there. Well, we have 2, 8 as a pair for the yellow, so this can't be 8, this is 6, which eliminates 6 here. This is 5, 8, and 6 there. So no more 6 here. Okay, this cannot be 7 anymore. Gray needs access to an 8. One of these two is 8. So it could technically go here and then here. And could this ever be the 8? And the answer to that is no. Well, we have a 7, 8, 7, 8 pair in column 2, so this can't be 7 or 8, it's 6. Eliminate 6 in the rest of the row. No 6, no 6, no 6. We are guaranteed a 5 here in the green. So gray could be gray here and then gray here, and that's 8. It could be gray here and gray here, and that's 4, and that's 8. So I think this has to be 8 here. If we try to make this 8 as a gray, the problem is that would force this to be 7, and that's the only way it connects, and then this would not have a 4 and an 8 left. So this could not be 8 either. This is a 4-7 pair, which eliminates 4 and 7 in the rest of the column. This is 8 and is gray, so this is not green. This 8 eliminates 8 here, so this is 7. There's no 7 here. There's no 7 here. So the blue needs access to a 7. It must then access 7 here. So this is 7, which means this is a separate region, so this cannot be blue. So this is done as boundary. We are missing a 4 or 5 or 6. It could be that one or it could be that one. We have a 4, 5, 6 triplet in row. Oh, this 8 eliminates 8 here. So this is 5, that's 8. Which eliminates 5 here and 5 here. Okay. Well, this could be 4. We have a 2, 4, 2, 4 pair in row 3, which eliminates 2 and 4 in the rest of the row. This can't be 4. This is 7. Yellow cannot be 7, so this can't be... This 7 eliminates 7 here, so this is 4, which eliminates 4 in the rest of the green regions. So this is 2, 5. This can no longer be green because it's a 4. So this can't be green. This is gray, which means we have the full gray here. This can't be gray. That's green. This can't be gray. That's yellow. So those are done as regions. 4 here eliminates 4 here, so that's 2. Which means this can't be 2 here. One of these 2 is a 7. This can't be 7 anymore, and this can't be 5 because of 5 and 7 in the column, so this is 6. No 6 here. This becomes a 4, 7 pair, which eliminates 4 and 7 in the rest of the column, so this is 6. 6 in the orange region means this can't be 6. This is 4. This is 6. So no more 6 in column. 8. This 4 eliminates 4 here. 4 here. This can't be 6 because of 6 in the column. So this is 5. This is 4. This cannot be blue. 4 and 6. 5 eliminates 5 here, so it's 7, which eliminates 7 here, so it's 4 and 7. This can't be 4. This can't be 4 because of the orange 4. Again, so this is 8. The problem is this region would be 2 here, 3, 4, 5, 7, 1, 6, and this would have to be 8 because this 8 would force this to be 2, which would force that to be 8, so this can't be 8. This is 5. That's 2. This is 5. 2 eliminates 2 here, so it's 8 and 2. So this is 5, which means this can't be 5. That's 8, so this can't be blue. This is orange. That means this can't be orange here. That's pink, which means this can't be pink. That's blue. And we have all the regions now. And this has to be 8. And that's a solution. I actually really enjoyed these deconstruction puzzles. It's a very interesting concept, right? And it's basically construction and deconstruction in the same puzzle, essentially, which is pretty cool. So I've been enjoying these. I think I've done a couple. I believe. I don't think I've done every single one. I think the setter wants to create ones from 4x4 to 9x9. I've obviously not seen the 9x9 yet. Actually, that's not obvious, but I haven't seen it. So anyways, I hope you've been enjoying these deconstruction puzzles, and I'll see you next time on Frank Puzzles. Take care.